Hi there, folks, and once again we are going to try something with SPSS. We are going to be working on ANOVAs today, and we're going to be doing both a between subjects ANOVA and a within subjects ANOVA, also known as a repeated measures ANOVA. So I've got a data set here, and what the experiment was they had a bunch of high school students with go-karts, and they wanted to test to see if sleep deprivation uh, affected the go-kart's driving ability. Um, so every time somebody hit a cone, they had a little court set up, a little driving course or whatnot for the go-karts set up. And if somebody hit the cone or hit hay or dinged off a wall or a tire, then they would have a point added to their score. So actually the higher point scores are more of a negative. And we have, let's first off look at our data. So I look at my data and I can see these are the points for people that had no sleep, people that had 4 hours of sleep, and people that had 8 hours of sleep. I can see here that this person right here, the first person, was a freshman, and that they did it with no sleep, they did it with 4 hours sleep, did it with 8 hours sleep. So I can already tell that this experiment was done over the course of 3 different days, maybe once a week, once a month, something like that. But they obviously did the same condition for each participant. I can see that I have freshmen, sophomores, juniors, and seniors, and I can see their scores from the 3 different times that they drove the go-karts. If I look over here at my labels, I can see that my data has been labeled, and that 1 stands for freshman. I can look, oh, senior is 4. Okay, so that's how they did it. That's great. So first thing we want to do is we want to run an ANOVA. Now the reason why we're running an ANOVA is because I want to know if there's a difference in means or averages between the groups, but I have more than 2 groups. So with a t-test, remember, if we want to test maybe if males are different than females, or if a pre-test is different than a post-test, there's 2 different, I'm looking at comparing 2 different means, and ANOVA is going to look at to see if there's a difference between more than 2 means. Let's first do what we call a repeated measures or a within subjects, and that's when each individual is in each of the categories or each of the conditions, excuse me. So right here, participant number 10, if I'm looking at this, I can see that participant 10 was in the category of no sleep and contributed to the category of 4 hours of sleep and contributed to the category of 8 hours of sleep. So what I want to look at is to see if all of the no sleeps, if the average is different than the average of all of the 4 hours and all of the 8 hours. So I'm going to run a repeated measures ANOVA. I'm going to go to Analyze. I am going to go to General Linear Model. I'm going to come over here to Repeated Measures. I'm going to click on Repeated Measures, and I'm going to give this a name. Oops, sorry about that. I don't know if it beeped in your ears, but it beeped in mine. I apologize. I have 3 levels. There we go. I'm going to give it a name. This is how much sleep they had, so I will just call it sleep. Maybe condition. That's kind of the name of the overall variable for all 3 of these. I'm going to add this. I want to define what those 3 are. So the first one that I'm going to define is my no sleep. The next one that I'll define for number 2 is my 4 hours of sleep, and the next one is 8 hours of sleep. And this is for condition 1, condition 2, and condition 3. Let's look at what they have to offer over here. Let's not get intimidated. Nope, we don't need that one. We don't need contrasts. We can do a plot if we want. Not really. There, we'll do sleep condition. Post hoc. Now we always want to do a post hoc, but for repeated measures, this is not where we get it from. This is actually where we get our post hoc for our between subjects ANOVA. I do want to go into options. This is extremely important. And I want to, well, for my sleep condition, I want to go to compare main effects. This is important because this is where we're going to get our post hoc. We're going to go to Bonferroni, as you can see. And this is where we'll get our post hoc analysis. I also want to grab my descriptive statistics. And I am going to hit OK. And what we see here, I can make this a little bit bigger. What we see here is this is just letting us know that sleep condition 1 meant that they had no sleep. Sleep condition 2 meant they had 4 hours of sleep. And sleep condition 3 that meant that they had 8 hours of sleep. I have my descriptive statistics. So I've got my mean and standard deviation for no sleep, 4 hours and 8 hours. And this is talking about the effect that we've got. I'm going to kind of skim over that because what I really want to look at is my Mauchly's test of sphericity. And I want to look at what my actual significance is. And if my significance is below 0.05, which it is, it means that we've broken some assumptions. So because of that, when I look at my F value for my ANOVA, instead of using sphericity assumed, I'm going to use the greenhouse geyser. So if it's below 0.05, I want to use greenhouse geyser. And if it's above 0.05, then I will use sphericity assumed. So again, this is below 0.05. I'm going to use my greenhouse geyser. And this is what I am going to read for my F statistic. So what this is telling me when I look at this F statistic is that it is actually significant because it is less than 0.001. So I now know that there is a significant difference in means between the no sleep group, the 4 hours group, and the 8 hours group. However, I do not know where the difference is. So I'm going to start my write-up from this. I'm just trying to make a little more room here. I need to get about a 60-inch screen, so I have a lot more room. And I kind of cheated and I wrote these out ahead of time just so I could save a little bit of your time. But I'm right here. I'm going to write about my repeated measures or my within subjects ANOVA. So let me get this set up and I will show you how to write this up. Sorry. Okay, repeated measures, also known as within subjects ANOVA, was run with variable x as the independent variable. So my variable, oops, just typed right in the wrong spot there. Okay, a variable x, there I am. So my independent variable is my sleep condition. And my dependent variable is, we'll call it driving score. And the results, like I said, the results actually, it is a 0, 0, 0, which is less than 0.01. So there is a significance. We can show that there is a significant difference between of driving scores between sleep conditions. And then I can kind of label what my conditions are. And I'm going to put in here, we have no sleep, 4 hours, and 8 hours. And I can put my F statistic in here. Now, whenever we do an ANOVA, we're going to have 2 degrees of freedom. We find our degrees of freedom from our within and our between subjects. So when I'm writing my F, I'm going to get my actual degrees of freedom. Here's my degrees of freedom column. And remember, we said because this is below the 0.000, below the 0.05, we're going to get it from Greenhouse Geiser. So my first degree of freedom is 1.034. And my second degree of freedom, I'm going to get down from the second half where it says error, I'm going to get from my sleep condition. And it's going to be 249.103. So this is from our between subjects groups, and this is our within subjects group. Or I just think I got that backwards. That's within and between. Anyway, nope, that's between, that's within. I tell you, see, I get confused after all these years myself. But we get the first original from the top, second from the bottom. Then we're going to put our actual F statistics. So we look across at the Greenhouse Geiser. And we can see that our F statistic is 17.785, which we can round to 79. 17.79. And our p-value, it does show that it is significant 0.000, which means that we write it as less than 0.001. So there is our F. Whoops, let me take out this equal sign. Should not be there. It's either equal or it is less than. It's not both. So that is our F statistic. We've now written our F statistic, but we're still missing both our descriptive variable, our descriptive statistics, and we're missing the discussion of how it's different. Is it, but what's different? Is the no sleep different than the 4 hours? Is the no sleep different than the 8 hours? Is the 4 hours different than the 8 hours? We don't know where the differences are. We know that there are differences, but we don't know where they are. So we're going to go back to our output and we're going to look at the next thing. And I'm going to go down a few lines and I'm going to look at these pairwise comparisons. And if I look, this is my multiple comparisons, or my Bonferroni. And the way that we want to read this is when I look at this, my sleep condition 1, it's going to compare that to sleep condition 2. And I come across, this is the difference in the means. So the mean of one minus the mean of the other was 2.45. I'm going to keep going across, and it is actually significant. Next, I can look at starting with sleep condition 1 and then comparing it to sleep condition 3. So this top row is sleep condition 1 to 2, and the second row is sleep condition 1 to 3. And there's the difference in the means, and that is also significant. And because it's set up like a matrix, I'm going to have a duplication here because this is comparing the means of 2 and 1, which we did first. We did 1 and 2. But it's the same information, same standard error, same significance. So now I'm going to look at 2 to 3, and I'm going to see here their difference. And it is not actually significantly different. So what this is telling me is that 1 is different, significantly different than 2, and 1 is significantly different than 3. However, 2 is not significantly different than 3. So how do we write that up? It gets a little wordy and it gets a little tricky, but here's what we want to do. I can put in my, let's see, what did I say? 1 is significantly different than 2 and 3. Okay. So I can put in my mean and my standard deviation for group 1, group 2, and group 3. Oops. So I can get them right here. Well, actually, it's not going to give me my standard deviation. I've got it right here. 5.65. And then I can fill in all the rest, which I'm just for the sake of time going to go a little faster here. Oops. Okay, so what type of post hoc did I do? I actually did Bonferroni. And it was telling me that group 1, now I don't want to write out the actual words group 1. I want to make it so that the reader has a better time understanding it. I know because I've been working with the data what group 1 is, but I'd like to be a little bit more clear for the reader. So I'm going to say that post hoc analysis revealed that the no sleep group, and then I can put their descriptives right there with their mean and standard deviation. And I'm going to say that they scored significantly higher and I know that because when I look at my descriptives, the no sleep average was 58, whereas the average for 4 hours was 55 and the average for 8 hours was 55. So they scored significantly higher than the 4-hour group, and I would put in their mean and their standard deviation, and the 8-hour group, and I would put in their mean and standard deviation. So this research would reject or fail to reject. We're actually going to reject the null hypothesis that there is no difference in driving scores for sleep conditions. And that is how I would write up the repeated measures ANOVA. Now let's go back to our data and let's see, I wonder maybe is there a difference in grade level? So what if I wanted to know if depending upon what grade they're in had an effect on their driving? Now if this were the case, I'm not actually interested in how much sleep they got. If I'm not testing for how much sleep they got, if I just want to know overall how did the different grades do, then I might want to run what's called a between subjects ANOVA. And this is because if you're a freshman, you can't be in the condition of senior. They're exclusive, they're mutually exclusive, so you can't be in both conditions at the same time. Whereas when I was looking at the sleep conditions, the subject was in all three conditions. So this time I'm going to run a between subjects ANOVA. But the way I have the data is I could either choose to do one, just see if there's a difference in grade level for no sleep, or see if there's a difference in grade level for 4 hours of sleep or for 8 hours of sleep. But let's say I just wanted to know overall, generally, all three of the tests, which grade level did better or worse. In order to do this, I want to create another variable. And I'm going to take an average of these three. I'd like to have an average of these three. So I'm actually going to go in here to transform. I'm then going to compute a variable because I want to make a variable that's based on computations from the other variables. Let's call my target variable average sleep. And what I want to do, I'm going to put my parentheses here. I want to make my own average, so I want to add the three variables together. I want to do no sleep plus 4 hours of sleep plus 8 hours of sleep. And then I want to divide it by 3. And a lot of people right here make a mistake because they hit the divide and they hit the 3 and then they hit OK. And if you look at this formula, if you guys remember back in, I don't even remember, 5th, 6th, 7th grade, we learned orders of operations. So if you keep it like this, you're going to end up with data that's like this. Now, if I just keep going and I'm one of these people that's always in variable view and I'm never in my data view, then I'm going to make a really big mistake. Because if I'm looking at my actual data, I can see here that participant number 1 had 51 points when they had no sleep. They had 64 points when they had 4 hours of sleep, and they had 46 when they had 8 hours of sleep. And yet for my average, I came up with 131. Well, just real quick in my brain, I can do one of these and I can add 51 plus 64 plus 46 and divide by 3. And I know that's going to be somewhere around 50-ish, 52 something, 51-ish, something around there. So I know this can't be right because I'm looking at my data. So just a quick reminder what we want to do. Remember, if I put that divide 3 inside of the parentheses, then what it's going to do is it's going to add the first one, the second one, the third score, and it's going to divide only this third score by 3. Only the third score. And that is the problem. If I, however, put it outside of the parentheses, then it's going to add the 3 together and divide the total by 3. So that's what I need to do. So I always look at my data and make sure I did it right, which we can clearly see I did not. Easy fix. I'm going to go into transform. I'm going to go into compute variable. I'm going to click right here. I'm going to take out that divide 3. I'm going to put it on the outside, divide 3, and I'm going to click OK. And it's going to ask me if I want to change the existing variable. Well, yes, I do, because the existing variable is wrong. So I'm going to change that, and boom, I've now got my variable has been changed, and 54 average of these three, that sounds about right. Sometimes I actually do even pull out a calculator and just check one or two. I might grab one down here in the middle just to make sure it works. So I now have my average amount, their average score, adding all the 3 different conditions of sleep. So let's run a between subjects ANOVA. I'm going to go in here. I'm going to go to compare means, because that's what I'm doing. And you recall the little t-tests we've done. Here's the independent and the paired. This time I'm going to do my one-way between subjects ANOVA. And what do I want to look at? Well, I'm going to take that average, the variable that I just made that has the average of all their scores from the different sleep levels and sleep conditions. And I'm going to put that in my dependent box. And I'm going to separate by my grade level. I definitely want to run a post hoc. I like Tukey. Some people like Sheffy. There are specific reasons why you would want to pick them, but this class is not about that. If you're ever confused or concerned, you can always go on the internet and find out. I want my descriptives. And I'm going to hit OK. And I have some more outputs. So I've got my descriptives here. I've got my freshmen. I've got my count of how many freshmen there are. And then their average, the freshman average, and the standard deviation, and the same for the sophomores, juniors, seniors. And I've got my total. So I want to know if there's a difference in grade level. I'm going to look at this box, my ANOVA box. And I see here that my significance is 0.001. So keep in mind, this actually is 0.001. I'm going to write an equals, not a less than. It is significant. And how do I write this up? So let's go back to my cheat sheet that I already started. And for my between subjects ANOVA, a one-way between subjects ANOVA was run with, and what is my independent variable? You guessed it, it is grade level. With grade level as, we don't need the word completed. You can tell I cheated and copied this from other things. With grade level as my independent variable and driving score as the dependent variable. Results showed, and yes, it was significant. A significant difference between let's put this, a significant difference in driving scores between grade levels. Freshman, sophomore, junior, and senior. And sometimes it's not as obvious as this. Sometimes you have different groups and it's not as obvious as freshman, sophomore, junior, senior. So it's good to put the groups that you're looking at. Remember that my degrees of freedom is going to have two scores. It's going to have my between groups and within groups. And my between groups is going to be a 3. And my within groups is next. So my degrees of freedom for between groups and within groups is 238. Two comma space 238. But my actual F score is 5.83. 5.83. And my p-value, like I said, it's 0.001, but this time we're not going to put less than. It actually equals 0.001. So I now know that there's a significant difference between grade level, but I don't know which grade levels differ. So I want to look at my post-hoc test. I come over to my post-hoc test, and again, I'm looking at a matrix. And this first line is going to tell me the difference between freshmen and sophomores. And the significance is 9.70. That is not significant. And my freshmen and juniors, 9.57. That's not significant. And freshmen to seniors, 0.003. Well, that is significant. So what I do as a little cheat, I just look at my significance and I say, okay, I just find the significance and I backwards, senior to freshman. Okay. Here's another one, senior to sophomore, senior to junior. So basically the seniors are significantly different than the freshman, the sophomore, and the junior. But the freshman, sophomore, and junior are not significantly different than each other. So remember I did a Tukey post-hoc. So when I'm writing this up, I am going to want to say Tukey, not turkey. Post-hoc analysis revealed that seniors and their mean and standard deviation scored, and let's actually go back and look at these. Seniors scored a 58, juniors scored a 56, sophomores scored a 55, and freshmen scored a 55. So seniors scored significantly higher than freshmen, and then their mean and standard deviation sophomores and the mean and standard deviation it should be italicized. Oops. And juniors. I want to add one more sentence though, because what I've discussed is I've discussed the relationship between seniors and freshmen and seniors and sophomores and seniors and juniors, but I haven't discussed any of the relationships between sophomores and juniors, freshmen and sophomore, freshman and junior. So I want to address all of them. However, the freshmen, sophomores, and juniors did not score significantly different from each other. And again, we would reject the null hypothesis that there is no difference in driving scores based on grade level. Gotta italicize my abbreviations. And of course these would be filled in with numbers, but I'm trying to save a little bit of time because this video is so absolutely exciting. I can't even imagine. That is how we run our results for ANOVAs for between subjects and within subjects. And I hope that in some way this helped, and you'll come to enjoy doing these, because at some point in time this gets kind of cool when you start to get a little more comfortable with it. Hope you have a great day. Thanks. Bye-bye.